Powered Parachute 5.1 Pre-Flight and Ground Operations. In the realm of powered parachutes, the journey begins with meticulous pre-flight preparations. Pre-flight and ground balance. This journey involves a comprehensive evaluation of three key elements encapsulated in the acronym PAVE: pilot, aircraft, and environment. The pilot's physical and mental state, the aircraft's condition, and the environmental factors must all align favorably before taking to the skies. Get ready to fly. Once the PAVE factors are deemed suitable for flight, a sequence of actions ensues. Weather briefing, checks on notices to airmen and terminal flight restrictions, flight planning, filing of cross-country flight plans, and heading to the aircraft mark the preparatory phase. This systematic approach is crucial for a safe and efficient departure. Trailering. Transporting powered parachutes via trailers introduces both convenience and considerations. Proper fitting of components, guarding against chafing, and secure storage within the trailer are essential. Before hitting the road, inspecting tires, lights, hitch functionality, and ensuring proper vehicle attachment is paramount for a trouble-free journey. Where to fly? The powered parachute's flexibility in transport introduces the need for contact with airport management at unfamiliar airports. Checking the airport facility directory for traffic patterns, no-fly zones, and special accommodations is vital. Compliance with Title 14 of the Code of Federal Regulations Part 91 is emphasized, highlighting the need for powered parachutes to avoid the flow of other air traffic. Operational considerations. Selecting an appropriate departure area is crucial for a powered parachute. Open grassy spaces, clear of debris and obstacles, are ideal, while concrete and asphalt surfaces, as well as lit runways, should be avoided. Considerations extend to respecting private property rights when using fields as airstrips, requiring permission and thorough checks for airspace violations or hazards. Takeoff and landing considerations. When selecting a takeoff position, careful planning is required to ensure clear paths, avoiding obstacles like fences, power lines, trees, and buildings. The importance of walking the entire length of the intended takeoff and landing area prior to departure is emphasized. Physical marking of potential hazards is advised to enhance safety during takeoff and landing. Pre-flight actions. Compliance with 14 Code of Federal Regulations Part 91 mandates several pre-flight actions. Pilots must familiarize themselves with all available information, including runway lengths, takeoff and landing distances, aircraft gross weight, and weather reports. For flights away from conventional airports, considerations extend to fuel requirements and alternative options in case the planned flight cannot be completed. A thorough understanding of these regulations and pre-flight procedures is crucial for a safe and successful powered parachute journey. Weather. The weather stands as a pivotal factor influencing all flight operations. A thorough weather briefing before each flight is imperative, encompassing current conditions, forecasts for departure and destination areas, and the route of flight. Sources such as www.nws.noaa.gov, 1800 WEX Brief, and specialized internet sites offer comprehensive weather information. Crosswind takeoffs should be avoided, and careful review of departure procedures is crucial to prevent potential challenges. Winds and powered parachutes. Powered parachutes operate optimally in calm air. Wind conditions, temperature, and dew point spread directly impact safe flight. Ideal winds are less than 10 miles per hour, with steady, non-gusting conditions being preferable. Crosswind takeoffs are discouraged due to safety concerns. Knowledge of the aircraft's performance in various wind conditions and adherence to manufacturer recommendations are vital for a powered parachute pilot. Temperature, humidity, and density altitude. Air temperature and humidity significantly affect powered parachute wing and engine performance. Understanding the impact of density altitude on flight is essential for safe operations. The higher the temperature, humidity, and actual altitude, the more critical density altitude becomes in determining takeoff and climb performance. A comprehensive grasp of density altitude is emphasized for safe powered parachute piloting. Clouds and visibility. Aircraft performance is influenced by different cloud formations and their associated effects. Maintaining adequate cloud clearance and visibility is crucial for safe operations in different airspace classes. Understanding thermals and turbulence, as well as recognizing their potential occurrence areas, enhances pilot awareness and safety. Visibility and minimums. Flying below minimum visibility requirements for the pilot's certificate and airspace class is strictly cautioned. Low visibility risks increase when air and dew point temperatures have a narrow spread. Strict adherence to regulations, manufacturer recommendations, and the development of personal minimums are essential for a powered parachute pilot. Weight and loading. Weight and loading considerations are paramount. Adherence to maximum gross weight specified in the pilot's operating handbook is crucial. Proper balance of pilot, passenger, fuel, and baggage within specified limits is mandatory for safe operations. Cart balance directly impacts safety, necessitating a balanced configuration. Pre-flight checklist. The utilization of a written checklist during pre-flight and ground operations is vital. It aids memory and ensures critical safety items are not overlooked. The checklist serves as an essential tool in maintaining the proper operational condition of the aircraft. Certificates and documents. The airworthiness of a powered parachute is contingent on specific certificates and documents. These include the Airworthiness Certificate, Registration Certificate, Operating Limitations, and Weight and Balance documentation. The pilot in command is responsible for ensuring the presence of these documents on board. Aircraft logbooks and inspections. Aircraft logbooks need not be on board during operation, but thorough inspection is recommended before flight to confirm compliance with required tests and inspections. Annual inspections within the preceding 12 months are mandatory, and additional inspections may be necessary for higher purposes. Maintenance records must be kept for the airframe and power plant. Pilot requirements. Pilots must possess a valid U.S. driver's license or a valid medical certificate accompanied by photo identification and pilot certificate. Sport pilots must carry endorsements indicating qualification for the powered parachute category, class, specifying wing shape and landing system. Visual inspection. The foundation of a safe flight lies in a careful visual inspection, regardless of the category, class of aircraft you will be flying. The purpose of the routine pre-flight inspection is twofold: to determine the powered parachute is legally airworthy and in condition for safe flight. A thorough and systematic pre-flight inspection of the aircraft and its components is essential, with adherence to the manufacturer's checklist. The following general areas are applicable to all powered parachutes. Pre-flight inspection process. Initiating the pre-flight inspection upon approaching the aircraft is key, especially as powered parachutes can be transported by trailer. Unloading provides an opportunity to scrutinize the entire cart for damages, low tire pressure, structural distortions, wear points, cart damage, and fuel or oil leaks. Removal of tie-downs, control locks, and chocks is a standard part of the unloading process. Familiarity with aircraft systems. Thorough familiarity with the locations and functions of aircraft systems, switches, and controls is essential. Use the pre-flight inspection as an orientation when operating a make, model for the first time. Walk-around routine. The routine, walk-around, involves 5 main tasks: cart inspection, power plant inspection, equipment check, engine warm-up and check, and wing and suspension line inspection. A detailed and systematic approach, consistently applied, ensures a comprehensive assessment each time the aircraft is flown. Cart inspection. Check the front nose wheel for proper play, tire inflation, and secure axle bolt. Test the ground steering bar connection points and ensure there is a smooth steering range of motion from the steering bar. Check and secure the connections between the front fork and the front axle and the front fork and the gooseneck. Brakes and seating. When brakes are installed, inspect the cable lock and brakes for rust, corrosion, loose nuts, bolts, alignment, and signs of hydraulic fluid leakage. Inside the cart, check seats, seat rails, and seat belt attachment points for wear, cracks, and serviceability. Verify the condition of adjustable front seats and associated mechanisms. Battery, ignition, and primer. Ensure the battery and ignition switches are off initially. Check the ignition switches and the operational status of the strobe if installed. Exercise the primer or primer bulb if equipped. Manipulate the engine throttle control and check the oil injection mechanism on 2-stroke engines. Altimeter and exterior inspection. Set the altimeter to the field elevation or barometric pressure if equipped. Turn on the ignition or engine instrument system master and note fuel quantity gauge indications. Inspect the exterior for signs of deterioration, distortion, and loose or missing bolts or lock nuts. Gently shake the cart to check for loose objects or airframe parts. Cable and steering check. Inspect all cables for kinks, frays, abrasions, or broken strands. Check each end of each flying cable for bolt security and confirm that thimbles are not twisted or elongated. Verify the freedom of movement and secure attachment of the steering bars. Rear wheel and axle assembly. Inspect the rear wheel and axle assembly, checking tires for proper inflation, cuts, bruises, wear, bulges, embedded foreign objects, and deterioration. Tires with cord showing or cracked sidewalls are considered unairworthy. Check the axle hardware, and ensure proper wheel rotation. This routine pre-flight inspection, although outlined here, should be performed in accordance with the specific checklist provided by the powered parachute manufacturer for the particular make and model of the aircraft. Thoroughness and consistency in the inspection process contribute to safe and reliable powered parachute operations. If you click like and subscribe and leave a comment, we will provide a coupon for a free PDF download, one of 9 ebooks. However, each individual can only download up to 1 out of 9 ebooks for free.